Good morning, guys. This is Miss Maydeck. I hope you had a wonderful weekend. Today in math, what we are going to be doing is we are going to be answering the question, can you use models to represent the multiplication of fractions? Last week, we focused on using models to represent addition and subtraction of fractions. This week, we're going to be doing the exact same thing, but we're going to be using multiplication. Now, the key word here is models. Now, we use models in mathematics to really represent what it is that we are talking about. I think models help us to understand math a little bit more deeply and really help us to understand why things work the way they work. So we're going to be doing that when representing multiplication. The first thing that I would like to do is to just go over the basics of modeling multiplication with an area model. So I'm going to use the equation 2 times 3. 2 times 3. In order to use an area model with 2 times 3, some of you might recall that you're going to be looking at the length and width of a rectangular region. The length, I'm just going to put as 2, and I'm going to represent that as the length of this, and the width will be 3 right here. Well, we can't just say 2 is the length and 3 is the width. We have to represent it some way by breaking up our model. So what I'm going to do is I'm going to break up my length into 3 equal sides and my width into 2 equal sides. I know that these aren't equal, but bear with me. Then I can see that I have 6 complete regions. So that means that I have my 2 times 3 equals 6. Another way of writing this is 2 groups of 3. Now keep this in mind when we are going through the fraction model next. So I'm going to give you an example here. We're going to start with the equation 1/2 times 1/4. Remember, this means 1/2 of 1/4. Keep this in mind as we go through the model. So just like the area model with the 2 times 3, I'm going to start with a rectangular region. What's different about this is we are not working with whole numbers, we're working with parts of a whole. So instead of one length representing 1/4 or 1/2, we're going to say that one length represents one whole. And you'll see what I mean in just a minute. So one whole length or one whole width is going to equal a whole. So what does that look like in terms of modeling with fractions? Well, I am going to say that this side is going to represent 1/2 and this side is going to represent 1/4, just like we did in the previous area model. What's different about this is that we are going to be splitting this up into what we have as our denominator. So I want to split this side up, the length side, up into 4s. Now I don't want to show all 4 fourths. I only want to use one of those 4s. So I'm going to shade in that 1/4 right here. Now we want to know what 1/2 of that 1/4 is as we represent it over here. Well, we're going to do the exact same thing we did with the 1/4, but we're going to do it with this side over here. So I want to break this length up into 2 parts. I only want one of them, so I'm only going to shade one of the 2. Now we've got all this shading, we've got all this scribbling, we've got our fractions. Well, what does this mean? Remember how I said that we're looking for 1/2 of 1/4. I know that this entire region right here is 1/4 of my shape. Well, what's 1/2 of that? That's going to be where I have half of that region shaded. A trick is to look for where they're both shaded in. We have green and maroon right over here. So this is going to be the region that represents 1/2 times 1/4. But what does that region actually mean? If this entire square is the whole, we have to figure out what this little piece of that whole is. When setting up my fraction, I'm looking for my denominator and my numerator. The denominator is going to represent the amount of equal pieces within my whole. I have 8 equal pieces in my whole, so I'm going to use 8 as my denominator. Then my numerator is going to be just that one little piece that I'm looking to represent, 1/2 of 1/4. And there's only one of them. So the answer to the equation 1/2 times 1/4 is 1/8, and we have just modeled it here. I'm going to do another example for you so that we can see how it's going, and then I'm going to give you a few problems to do on your own. Let's do 2/5 times 1/3. Again, remember, this means 2/5 of 1/3 of 1/3. Okay, so we're going to model this using that same area model. I'm going to make it a little bit bigger because I see that I have larger pieces that I need to represent. Okay, remember, one side equals 1, but we want to represent 2/5 of one side. So we're going to start with 5 pieces. Bear with me. I'm going to try to make them as equal as possible. And then I only want 2 out of those 5. So I'm going to shade in 1, 2. So we've got 2/5 of our whole is represented. Now we want to figure out, well, what's 1/3 of those 2/5, or 2/5 of the 1/3? Either way, you can flip-flop back and forth with the commutative property of multiplication. So if I'm using 1/3 on this side, I'm going to break this up into 3 equal pieces, using air quotes right now. And I'm going to just show 1/3 of that. So I've got 1 of the 3rd I'm going to shade. Now remember, I want to know what 1/3 of the 2/5 is, or 2/5 of the 1/3 is. I'm going to look for the region where both of the colors are represented. So that's only 2 pieces. So that means that my numerator is going to be 2. Well, my denominator should represent the number of pieces I have altogether. I know that I've done 3 pieces on this side, 5 pieces on this side. I have 15 pieces in total. Another way to do that is to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I know that 2/5 of 1/3, or 2/5 times 1/3, equals 2/15. On your own paper, I want you to represent a few different fractions using area models. The first one that I want you to do is 1/4 times 2/3. So that's the first one. The second one I want you to do is 5/6 times 4/5. Third one I want you to do is 3/4 times 1/6.
Morning. This is us working on
excuse
that
me.
cell breakout. I'll see you down in the library.
And the last one I want you to work on is 1/2 times 5/7. Make sure that you are modeling each one of these problems using that area model. This will be due at the end of the period today. When you are done, you can grab the handout from your substitute to practice using area models with multiplication. That one will be finished for homework if you do not finish it in class today. I hope that you are having a great day, and I look forward to seeing you after break.